Imagine the year 2050. A small but growing human settlement stands on the surface of Mars. Transparent domes protect carefully designed habitats. Inside them, people walk without spacesuits, breathing recycled oxygen, growing food in controlled greenhouses. But turning this vision into reality is far from simple. Mars is not just another destination in space. It is one of the harshest environments humans have ever considered visiting. The red planet is colder than the most extreme regions of Antarctica, with average temperatures around -60 degrees Celsius. Its atmosphere is extremely thin, less than 1% the pressure of Earth's atmosphere, and it is made mostly of carbon dioxide. If a human were to stand on the Martian surface without a protective suit, the consequences would be immediate. The low pressure could cause bodily fluids to begin evaporating. Oxygen would be absent, and suffocation would occur within minutes. In other words, Mars is not naturally habitable. Every breath, every drop of water, and every degree of warmth would need to be created artificially. The challenge begins with distance. While missions to the Moon take only a few days, traveling to Mars is far more complicated. At its closest approach to Earth, Mars is roughly 56 million kilometers away. Traditional mission designs suggest that a spacecraft would need 6 to 9 months to reach the planet using current propulsion systems. During that entire journey, astronauts would live inside a spacecraft, exposed to cosmic radiation, isolated from Earth, and unable to return quickly if something went wrong. Because of these difficulties, many experts believe that robots will lead the way long before humans arrive. Advanced robotic explorers could begin building the first infrastructure on Mars years in advance. Imagine hundreds of automated machines spreading across the dusty terrain, digging beneath the surface to locate frozen water, assembling solar power systems, and constructing protective shelters. Some future mission concepts even imagine fleets of nearly 100 construction robots working together, preparing landing zones and assembling the first habitats for future settlers. Artificial intelligence may also play a crucial role in these early operations. Companies on Earth are already experimenting with AI-powered humanoid robots designed to assist with complex physical tasks. One example is the Tesla Optimus humanoid robot, developed by Tesla. While still in development today, such machines could one day perform dangerous or repetitive jobs in environments where human labor is extremely risky. On Mars, intelligent robotic workers could maintain equipment, repair habitats, transport heavy materials, and operate around the clock without the limitations that humans face. Transportation technology will also be a key factor in making Mars exploration practical. One of the most ambitious spacecraft designs currently being developed is the SpaceX Starship, created by SpaceX under the leadership of Elon Musk. Starship is designed to be fully reusable and capable of carrying large amounts of cargo across interplanetary distances. The spacecraft is intended to transport not only astronauts, but also heavy industrial equipment, construction tools, and life support infrastructure needed for building a settlement. Some early mission concepts imagine several Starship vehicles landing on Mars during the same launch window. In one scenario, as many as 5 spacecraft could reach the surface in a single campaign. Each vehicle could deliver roughly 10 tons of payload, ranging from robotic equipment and power systems to supplies needed for early exploration. These first cargo missions would not establish a city immediately, but they would begin laying the foundation for something much larger. Another important part of the strategy involves using the resources already available on Mars. Scientists refer to this idea as in situ resource utilization. Instead of transporting every single material from Earth, future missions could extract water ice from underground deposits, separate it into hydrogen and oxygen, and use those elements to create rocket fuel and breathable air. Martian soil could be processed to produce building materials, metals, and protective shielding. Over time, these local resources could support the development of small industries operating directly on the Red Planet. Energy production will be another essential requirement. Solar power is considered one of the most practical options, especially in the early stages of settlement. Large fields of solar panels could generate electricity to power life support systems, scientific laboratories, and robotic operations. However, Mars is also known for massive dust storms that can cover the entire planet. Engineers must therefore design power systems that remain reliable even during weeks of reduced sunlight. Beyond the technical challenges, there are also human challenges. Living on Mars would mean enduring long periods of isolation and confinement. Communication with Earth would involve delays of several minutes, depending on the relative positions of the two planets. Astronauts could not rely on real-time instructions from mission control. Instead, they would need to make many decisions independently while operating millions of kilometers away from home. Despite all these obstacles, optimism about Mars exploration continues to grow. Over the past 2 decades, robotic missions have dramatically improved our understanding of the planet. Rovers have discovered evidence that ancient Mars once contained rivers, lakes, and possibly even oceans. These discoveries suggest that the planet may once have had conditions capable of supporting microbial life billions of years ago. This possibility alone makes Mars one of the most fascinating destinations in the solar system. If signs of ancient life were ever discovered beneath the Martian surface, it would fundamentally change our understanding of biology and the history of life in the universe. For scientists, that question is one of the strongest motivations for exploring the Red Planet more deeply. At the same time, technological progress continues to move forward. Reusable rockets have dramatically reduced the cost of launching cargo into space. Advanced robotics and artificial intelligence are becoming more capable every year. Life support systems designed for long-duration missions are being tested aboard orbital stations and experimental habitats on Earth. Step by step, the idea of reaching Mars is shifting from speculation toward engineering reality. The process will likely take decades, and many challenges remain unsolved. But the direction is clear. Humanity is slowly building the tools required to travel farther than ever before. And if those efforts succeed, the dusty plains of Mars may one day become home to laboratories, research bases, and perhaps even the first permanent human city on another world. The Red Planet, once visible only as a distant point of light in the night sky, could eventually become the next frontier of human civilization. If you enjoyed this video, like the video and subscribe to the channel for more interesting documentaries like this.